Welcome to this eLearnSecurity video lesson on Social Engineering Linux Targets. In this video, we're going to demonstrate how we can create a social engineering ruse designed for users of Linux machines. By now, you're probably familiar with client-side attacks that are typically geared towards users of Windows operating systems, whether it's a malicious Microsoft Office document that downloads and executes a payload, or through spear phishing or drive-by download attack vectors that exploit browser vulnerabilities, but we rarely are called on to create a social engineering ruse designed to target users of Linux desktop systems. When we are called on to exploit also users of desktop-based Linux systems, we can use this specific technique to obtain a reverse shell from a Linux user's desktop system. For this demonstration, we will exploit a certain functionality within what are known as .desktop files. .desktop files are very similar to the .lnk files on Windows systems and allow us to create a shortcut to an application. In this case, we can exploit a .desktop file to pull a remote payload, executed on the target system under the guise of displaying a PDF file to the user. Our target operating system for this demonstration is Ubuntu 12.0.4 LTS, as we can see here. Before we continue, let's first have a look at some of the elements that are required for a working .desktop file. On our desktop, we've created a bare minimum version of a .desktop file we can use as an example. As we can see here, we first start with the desktop entry element. This is basically just a field that tells us this is a .desktop file. It is not required for a functioning .desktop file, however. Next, we need three more elements, which are required for a basic .desktop file. The first element is the type element. The type element specifies the type of the .desktop file, and there are three types we can use: application, link, or directory. For this attack scenario, we're going to use the application type as we can see in our example. Next, we have the name element. This is the file name that will be shown to the end user. In our case, we've changed the name element to read document.pdf. We can see that currently our .desktop file has an extension of .desktop, as we view it on the desktop. But after we add our name element and save the file, we'll see that the extension will actually be hidden from the user, and will be shown as document.pdf. The third required element is the exec element. This element allows us to specify a command that will be run when the user opens the .desktop file. Let's test this by adding an exec element that will initiate a netcat reverse shell to our attacker machine. First, we'll create the command line necessary in the exec element, and we'll save the file. And an important change we need to make is to ensure our .desktop file is marked as executable. We'll use the chmod+x command to do so. Next, we'll open up an SSH session to our attacker machine just for demonstration purposes and start a netcat listener. Now, we'll execute our document.pdf file which should initiate a netcat shell to our attacker system. As we can see, we've gotten a reverse netcat shell from executing the document.pdf file, which is really test.desktop. Now, we've seen how we can use the exec element of a .desktop file to include a command of our choosing, but we still need to perfect our attack vector. For instance, changing the icon of our .desktop file. For this, we can use the icon element. For this particular element to be successful from a social engineering standpoint, it would be wise to know the operating system of your target. For instance, on our Ubuntu install, we can find several SVG files we can use as an icon for our malicious.desktop file. If we do a quick locate for *pdf.svg with asterisk as our wildcard, we can find some icons we can use to give our .desktop file a PDF icon. For our example, we'll use the following application-pdf.svg file as the icon for our .desktop file. We can add our icon element to include the path to that icon, as seen here. Once we add that element and save our file, we can now see that our .desktop file has a PDF file icon. This makes it a little bit more convincing for our ruse. So far, we've created a .desktop file to masquerade as a PDF file by changing its icon element. And we've also included a netcat reverse shell to our attacker system with the exec element as well. This is all great, but we need to take it a couple of steps further. Since when the user clicks on our current .desktop file, nothing will happen from a visual perspective to our user, this could be a red flag, and we want to better perfect our ruse. We need our .desktop file to display a PDF to the user when they click on it. And we also want it to give us an interpreter shell on our attacker system. There's a tool we can use to help us automate the creation of a more complex .desktop file, which is known as lindrop, which is a Python script and can be downloaded from the following link. There's also a blog post that summarizes this concept at the following URL. We've already downloaded the lindrop.py script and have it on our desktop, as we can see here. When we run the lindrop.py script, we'll be presented with some input fields. We'll walk through each one. Let's run the lindrop.py script first. First, we're asked for the name of our output PDF file. When we created our .desktop file manually, we used document.pdf. We'll use infrastructure_2018 for our new ruse. This is the name of the file that will be displayed to the user. We don't need to include the file extension here. Next, we're asked for an output zip name. Lindrop will automatically create a .zip and a .tar.gz file, which will contain our .desktop file. This makes it easier to deliver to the target. We can use the same name, infrastructure_2018, as the name of the zip, and .tar.gz file Lindrop will create. Next is the remote payload URL. This is a URL to where a remote Linux-based payload is hosted. The .desktop file will fetch this remote payload and copy it into the user's /temp directory. Before we enter this, let's quickly generate a Linux-based payload on our attacker machine, prepare a multi-handler and a Python web server, which we'll use as the URL to our payload. We'll call our elf executable payload for our demonstration. First, we'll generate our payload. Next, we'll prepare a multi-handler for our listener. Lastly, we'll launch a Python simple HTTP server to act as our remote payload URL. We'll open up a new SSH session on our target for this demonstration, and since we need one terminal for the handler and another for the Python HTTP server in this case. Once we've prepared our remote payload, started a handler and a web server to serve our payload, we can use that in the remote payload URL on the lindrop tool. Lastly, we are asked to enter in the URL to a remote PDF file. Lindrop will download this PDF, copy it to the /temp directory, and will display it to the user once they click on the generated.desktop file. We can also host the PDF on our attacker system. For the sake of demonstration, we'll copy a PDF that already exists on our attacker system to our Python web server location. We'll then use that as the URL for the remote PDF. Once we hit enter, we'll see that Lindrop has now generated two new files, as can be seen on our desktop here. One is a .zip, the other is a .tar.gz file. We can send either one to our target user. Ideally, this can be done through email, delivered over chat software, uploaded to an organization's website through an exposed upload form, etc. We can use our imaginations here. Now, let's extract one of these to see what we end up with. We'll extract the .tar.gz file. Once extracted, we can see our malicious.desktop file on the desktop here. Once we execute the rogue PDF file, two things should happen. One, the file will download and use events to display the PDF file to the user. And second, our payload will also be downloaded and executed, which should result in us receiving a reverse interpreter shell on our attacker machine. Let's see what happens. And as we can see, everything worked as planned. A PDF was displayed to the user, and we also have a reverse interpreter shell. We can continue to our post-exploitation phase of the engagement from here. And this concludes our video lesson on social engineering Linux targets. Thank you for joining us.